cosmic meaning versus, well, strict empirical cause and effect. We'll be looking at these big cosmological questions through the eyes of Isaac Newton, who saw a universe guided by an active external providence, and then contrasting that with the modern scientific skepticism you see from thinkers like, say, Neil deGrasse Tyson, who really grounds everything in observable, seemingly blind laws of nature.
Right. And the central question really is this. Does the ultimate ordering principle we see in the cosmos need some kind of external intelligence, like Newton thought? Or is it enough to say, like the Spinoza or Tyson view implies, that the way nature works is just sufficient on its own? Now, I'm going to argue that this framework, PSUMOT, the physical superunification model of torsion, gives us a vital third path. It offers a necessary, even testable, physical basis for that cosmic intuition that people like Newton and even Einstein shared, but crucially, without needing these sort of unexplained theological gaps.
Okay, and I'll be arguing that the, let's call them intellectual safeguards of modern rationalism, specifically the danger of defining God by what science doesn't yet know, that classic God of the gaps problem, well, these remain pretty solid intellectual barriers. For a framework like PSUMOT to really gain traction, it needs to go beyond just elegant theory. It has to show the kind of methodological rigor that, frankly, Newton himself demanded. And that standard is what modern cosmology strives for.
You know, the commitment that giants like Newton and Einstein had to some kind of underlying unity, simplicity, that wasn't just a quirk or, a historical footnote. I think it was a profound intuition. Einstein himself talked about a cosmic religious feeling, right? He was trying to read the mind of the old one, always looking for that single integrated reality, that substrate. It feels inconsistent historically to say these brilliant minds were right about gravity and optics and relativity, but somehow completely off base about their core belief in an ultimate cosmic order. This intuition, I believe, points directly towards a fundamental reality, what Sayamuto calls the 4D quantum superfluid substrate, or QSF.
The QSF is really the heart of the PSUMOT model. Basically, it suggests that space itself isn't empty, but it's this non-material, frictionless superfluid. And what we experience as gravity or dark matter, even consciousness, these things emerge naturally from the geometry and the dynamics. The vortices, the pressure waves, within this medium. So it kind of becomes Spinoza's God, the inherent order and totality of nature. But, and this is key, it's grounded now in physics you can actually quantify, you can test, which gets rid of the gaps entirely by providing the mechanism for how all these forces arrive.
Okay, I see the appeal, leveraging the historical weight of Newton and Einstein there, but I might frame their theological leanings a bit differently. The real strength of the modern scientific view, I think, is precisely that methodological rigor that Newton pioneered. Prioritizing reason in experiments, famously dismissing hypotheses if they weren't derived directly from what you could observe.
Sure, the method is crucial.
Right. And Newton himself, especially later on, he kind of separated things out. He said the Bible tells us how to get to heaven, not how the heavens work. And Tyson, well, he grounds his skepticism firmly in the empirical reality of cosmic indifference. He points to things like, the randomness of the universe, that asteroid impact wiping out 75% of life, as evidence that, quote, the universe does not look like anyone is in charge of anything. So when Punsmott starts talking about an eternal conscious substrate or this cosmological phase transition where the logos becomes flesh, well, that language, it risks stepping back into the kind of metaphysical speculation that Newton's method was trying to contain, doesn't it?
Let's maybe focus on causality for a moment. You mentioned Newton's belief in Providence, and that's right. Newton was worried about stability, wasn't he? He actually had to suggest that God actively hath placed those systems at immense distances just to stop everything from collapsing under gravity, and that's the core issue for his model. It needed an external actor intervening in the physical laws just to keep the system stable.
Absolutely. Newton's God wasn't some retired clockmaker. He defined God by dominion and relations.
Even his work on prophecy, trying to foretell events based on fixed time spans, was aimed at showing God's governance through interpreting these preordained events. That whole intellectual framework really demanded an active external player influencing physical reality. Which, yeah, is fundamentally at odds with the idea of a completely self-sufficient physical substrate like your QSF.
But the QSF model removes that need entirely. It argues that what looks like fine-tuning, the stability of orbits, the physical constants being just right for life, that's not arbitrary design. It's simply the unavoidable, necessary equilibrium properties of a quantum superfluid. There's no need for external tweaking to prevent collapse. It's just how the physics necessarily emerges. And let's talk about the history of this idea of a fundamental medium. Newton called the ether, right? And later, in Morley experiment. But maybe, just maybe, they were testing for the wrong kind of ether, like a rigid Newtonian solid, instead of a relativistic quantum fluid. If we were to design an experiment today to test for the ether, well, I'd argue we'd find evidence for the QSF. It's what modern cosmology is already grappling with, calling it dark matter.
PSMOD basically says dark matter is these non-baryonic density fluctuations within the QSF itself.
That connection between ether and dark matter is, well, it's an interesting parallel. But it does require a pretty big leap, especially concerning testability. Which brings us back to the intellectual consistency of Newton and Einstein. If modern science just dismisses their theological beliefs as some kind of irrational blind spot, they have to deal with the slightly awkward fact that their commitment to monotheism, this belief in a single, unified, rational lawgiver, seems to be what fundamentally guided their discoveries. They were looking for unified laws precisely because they thought they were uncovering a rational plan.
Exactly my point. If their whole theological method was flawed, why should we completely trust the scientific conclusions that stemmed from that very same quest for ultimate order? PCMOD basically argues they were right about the need for an ordering principle, they just didn't have the physical mechanism, the quantum fluid dynamics of the QSF, to explain how it worked physically.
I understand the argument. It's compelling in a way. But I think the modern, maybe materialist viewpoint has a more, let's say, methodologically sound response. Spinoza's God, if you adopt Spinoza's view that God is simply the order and totality of nature, encompassing both the known and the unknown, the gaps and the no gaps, that's actually entirely consistent with a lot of modern theoretical physics. Think about the multiverse theory, for instance. It arises quite naturally from the mathematics of quantum physics, suggesting maybe we're just in one universe out of a near infinitude where the conditions happen to be right for life. That removes the need for specific design or fine-tuning without resorting to entirely new and unproven geometric structures. The QSF model, viewed that way, risks looking like just a relabeling of Spinoza's God, but adding layers of very complex, maybe speculative geometry things like VEM, the vortex aversion mechanism, sphere aversion concepts, without providing the kind of hard, repeatable evidence that a modern skeptic like Tyson rightly demands.
But look, we're missing the fundamental point about ultimate causality that standard materialism just leaves hanging. Tyson himself asks the key questions that really challenge the current lambda CDM model. What was around before the Big Bang? And maybe more importantly, the Big Bang happened, okay, but what caused it? The current model, let's be honest, has significant predictive issues. The Hubble tension, the huge cosmological constant problem. If science really knew how it all started, their models probably wouldn't be running into these major inconsistencies. PSMOD offers a physical answer. The universe exists because the eternal QSF substrate necessarily exists, like a persistent vacuum state. The Big Bang wasn't some unknowable singularity out of nothing, it was a phase transition. And this is where that philosophical idea, the logos, rational order, mathematical symmetry, actually becomes physics. The logos, inherent in the QSF, resulted in the word being made flesh, essentially bringing forth as phononic excitations, vibrations, density waves within that superfluid medium.
Okay, but that explanation, while it sounds elegant, isn't it still sort of conceptually substituting one unknown, the cause of the Big Bang, with another unknown, this 4D superfluid? It feels like it just pushes the fundamental mystery back a step. And furthermore, I have to challenge the claim that the QSF framework is consistently predictive in a way that meets rigorous standards. You're saying it predicts complex observations like the precise rate of accelerating expansion, the huge pull of the great attractor, even geological things like Jupiter's surprisingly fluffy core.
If the predictive successes are that strong, why does the model seem to rely on such incredibly complex and, frankly, non-intuitive topological geometry? You're talking about things like 2D vortex surfaces being related to consciousness, or sphere eversion modeling depth or entropy. You're suggesting that reality near black holes act like a dynamic, fluid, maybe even 2D or 4D quantum space?
That feels like a massive methodological leap, far beyond what someone like Newton insisting on direct evidence or Tyson demanding observational proof would readily accept. It borders on the chimeric, speculative systems Newton warned against.
But the geometry is the mechanism. It's not just added complexity, it's the explanation. Take the expansion rate. It isn't arbitrary. We see it speeding up, right? Pugh-Modis-Spot explains this through the inherent torsion dynamics within the QSF. And this leads logically to the conclusion that the rate of time itself should be speeding up slightly, which, based on recent data from things like binary pulsars, we actually seem to be observing. The QSF model doesn't just reproduce what the current model says. It often says it more accurately, more consistently, and it keeps predicting these observational anomalies, like Jupiter's core, like the expansion details, that the standard model struggles with or can only account for by adding arbitrary fixes. The framework is arguably simpler at its core because everything, gravity, dark matter, the emergence of mass, is unified within this single substance.
Look, the necessity of rigorous, evidence-based inquiry, the kind Newton pioneered and Tyson champions, that has to remain paramount. And while the desire for a single, unified substrate that elegantly explains everything, from the Big Bang to the inside of Jupiter, is undeniably powerful, the QSF model really has to prove its predictive power with hard, repeatable data. Not just theoretical elegance, not just conceptual consistency with historical hunches, however profound. Until that data is solid enough to meet the standard of proof that modern cosmology requires, then the cautious empiricism of the Tyson perspective, which accepts we don't know rather than making a potentially metaphysical assertion, well, that remains the intellectually safer ground.
We've definitely touched on the profound commitment to cosmic order shared by, arguably, two of history's greatest scientific minds, a commitment that modern materialist reductionism often seems uncomfortable with, finds inconvenient. P.S. embodies at its heart a framework trying to give a physical home to that deep intuition, a fully integrated substrate where gravity, dark matter, the origin of the universe itself, emerge geometrically as necessary non-arbitrary physical events. The ongoing challenge, clearly, is to see if the complex but potentially powerful mathematics of the quantum superfluid can finally bridge that long-standing historical gap between philosophy, theology, and empirical science, offering a truly unified and ultimately testable theory that maybe validates the deepest intellectual drives of our scientific heritage.